Okay, welcome everyone. My name is Ileana Betancourt. Welcome to tonight's webinar, Become a Graphing Question Expert with Edulastic. We have a great session ahead, and we're really glad to have you here with us. Before we get started, we have a couple housekeeping items. First of all, tonight's event will be recorded, and you will be emailed the recording in about 24 hours. We will be posting it on our YouTube channel as well. And if you are looking for a certificate of attendance, you'll have an email emailed out 24 hours from now that will serve as your certificate of attendance. If you've never done a Edulastic webinar before, webinars are a little different than meetings. We have a Q&A box where you can put all your questions you have. We'll answer the questions as best we can. At the end of the session, we will have a designated time for questions and answers. That'll be about 10 to 20 minutes, depending on what time we get there. We want to make sure that today's training is as helpful as possible to you. So again, my name is Ileana Betancourt. I've been working in education for about 10 years now, helping connect teachers with really awesome resources. I've been with Edulastic for almost 5 years. It's a great platform, and we're really excited to show you the ropes on graphing today. To those of you who are brand new to Edulastic, you might want to learn the basics. We're not going to go into the basics of Edulastic here. So if you could head over to the YouTube channel at some point later to take a look at an overview of a basic Edulastic account, free teacher account, that would be a really great thing for you to do to get an idea of how everything works. And Jan's going to enter that link into the chat for you. Today, on today's webinar, we do have a giveaway that we're doing. So we're about to release Spark Math, which is practice content. Everyone who's here today is entered, so very exciting. And the winner will be announced at the end of this seminar. Spark Math is curriculum-aligned practice for students, and it helps recommend work for your students to do. So stay to the end, and you will be entered to win, and we'll announce that winner later. We have a couple info sessions on February 17th and February 23rd to those of you who are interested in learning more about Spark Math. And maybe Abel or Jan can enter that into the chat. In addition to me, we have my colleagues Abel Gonzalez and Jan Moody online to help with answering questions and responding to your comments in the chat as well. So again, today we're focusing all about creating graphing questions. Edulastic has a lot of ways to create rigorous graphing questions. This year especially, there were a lot of new features added. So we're really excited to show you all there is to know about doing that. To present the core of this presentation today, I'd like to introduce my colleague, Dr. Lawrence Chernin. Dr. Chernin began his career as an astrophysicist at Berkeley after completing a PhD at Harvard University. He has over 20 years of experience in technology development, and he is the proud architect of Edulastic math questions and also in the graphing questions that we're going over today. So with that, Lawrence, I'd love to invite you to turn on your audio and video and take over the sharing and the presentation from here.
Thanks, Ileana. Thank you everyone for joining and welcome. And I hope you're having a great afternoon or evening. I know we have a lot of stuff to cover, and we will stop along the way for questions. So every 10 minutes or so, we'll stop and pause. And so if you send your questions through the chat or the Q&A, Ileana will compose them, and then we'll go through those in the pauses. So let's go on. So the test I'm going to show you with sample questions is available. It's public, and Ileana will post that link in the chat. So before I go into live examples, I just want to go over background with graphing questions. And this is how you can get to graphing questions. By the left-hand side navigation, there's a specific category called graphing. And what we mean here is really graphing evaluation. You can always create questions with graphs, like even in a multiple choice question. But graphing evaluation is about recognizing equivalent forms of objects and evaluating at a deeper level. And so I'll show you what that means. And that will give you a way to deeper probe the skills that you think the students have. So for graphing, we actually have subcategories. And let me close this. So there's 6 subcategories. In the top corner, you'll see graphing. There's also just first quadrant graphing, placement, and then there's some number line related topics and fraction editor. Those are sub aspects of graphing, but I'm going to consider the general graphing, which is the top left box here. And so I'm going to click on that. And then you will see, oh, before I show that, we also have charts questions. So under graphing, there's charts. I'm not going to cover that today, but just wanted to mention that because that might satisfy some of the other question types that you need to go through. So once we get into graphing questions, the general question will look like this. And so there's down the left-hand side, there's a navigation. So there's a navigation or series of steps you can go through to compose your question. And if you're a free user, you may not have all of these settings. So these are generally all available in the premium mode. But I think everything I cover in this presentation, all the features are available for free users as well. So I'll just mention in passing that we'll talk about the grid section and also the particular aspects here, the objects like a line and a point. So on the next slide, now we have the different graphing objects, and you'll see this here with the plus sign. You'll see as I click through the plus sign, it brings up different graphing objects. So here's a circle, and we also have all these other different cases, and you can do more general graphing as well. And I'll show examples of that. And so here, the next thing, besides selecting the graphing object, on this slide, I show there's a point object, a line, a sign function. There's also area selection mode. And then there's evaluation controls, which are right below the grid. So you can change those controls to get different evaluations happening for your graphing questions. And so then when you open up those evaluation settings, these are the different options that allow you to test for different things in the question. So for example, here we have a check to find parallel lines. So this would come up if you wanted to ask the students to draw a line parallel to, or you could say draw a line parallel to the x-axis, or a line that's parallel to another line with a 45-degree slope. So the is parallel check will consider all possible students' answers and see if they're under this condition of being parallel. So that's how these evaluation settings work. And so I should also mention that you can help the students along with your questions, and there's specific calculators that are available, and these can be configured on the test settings. There's a basic calculator, and there's also a scientific calculator and a graphing calculator. So you can enable these for the students, and you can also give hints. There's a section at the bottom when you're composing the question, so you can give multiple hints to help the students get through the questions. And so I'm going to go through live examples showing a session within Edulastic. And I'm going to cover these examples with coordinate points. And when I talk about coordinate points, I'll also show how to do partial credit. And then I'll also talk about polygons and similar shapes. And then we'll talk about lines and inequalities, and then the grid. And I'll also cover some background shapes and how you could use tolerance. And then we'll look at some specific objects like a circle and what it means to implement a circle, and then trig functions, and finally general graphing. So I'm going to switch my screen to actual questions in Edulastic. Can you see those?
Yes.
Okay, great. So I have 6 examples which follow from what I was talking about on the previous slide. And the first question we're going to talk about is plotting points. So I'm going to open this up. I've already authored these questions, but I'll show you the steps to author them. So here is an example question, and we're going to start out with easier questions, and then things will get more complicated. So bear with me here. So I have the point object selected, And the question is plot 2 points, 1, 4 and minus 1, 7. So I have to mark the answer. So I have point A is the first one and point B is the second one. This is the correct answer. And here is what I mentioned, the change of the evaluation settings. And this will open on the right-hand side. We don't need to change any of those right now. And then this is the navigation I mentioned on the left side. And there's a, let's look at this grid briefly. And this will take you to the section where you can configure the grid. And then I'll go back to where we were before. So the free users won't have all of these, but you can still change the grid through these. There's a tool button here that will open up grid control. So you can change it, say, instead of from -10 to 10, say you want to go from -2 to 2. And this is the grid interval. Instead of being an integer spacing, you could have it 0.5 or a quarter. That's how you can control the grid. And you can zoom in or zoom out. So once we specify our correct answer by clicking points, so let's say we had 3, I just added point C, but I don't want that, so I'll undo that. Oh, it undid everything. So let's compose it again. My first point is 1, 4, and then the second one is -1, 7. So there are the 2 points. So as a part of authoring, the next step would to go into preview mode and check how the answer behaves. So in preview mode, we will actually try out different things. So I'll just enter some random points and check answer, and it's graded as incorrect. These are the wrong points. I could also show the answer to see what a correct answer should be, and that's shown below. And now I wanted to mention how partial credit would work. Say I only had one of the 2 points correct. If you want to enable partial credit, that's part of the scoring section. So there's a scoring type, partial match or exact match. So here I have set it to partial match. And so now we'll go through and let's just enter one of the points correctly. And I'll enter 1, 4. That point A, the first point is correct. And the second point, I'll just put it up there. So now the score would be a half. I'm going to check the answer, and this is partially correct, 0.5. So this is how you can enable partial credit. And so, for example, with points, I'll show you also, you have to enhance this question, you can add background shapes. So there are all these same objects you can add into the background. So here I added a circle. Now it shows in the background, and it would also be presented to the students. So that is the idea of background shapes. So let's remove that. I don't want that background shape. So that's gone. And I showed you the partial match for partial scoring. There's other partial scoring modes. And this does get rather complicated, so I'm not going to talk about this here. We have many different ways in which partial scoring can be given, so with penalties, and depending on the question type, it can also behave differently. And so here are the grid controls, and below that we have graph controls you can configure, and you can configure the labeling on the graph, and you can also upload a background image. And a useful thing, as I mentioned before, is hints. So if you want to give the student some hints, I'll put that in there, and I'll have a second hint here. And so if the student is looking at that and they scroll to the bottom, they will have their hints, the first hint, and then they'll get the second hint. So that might be useful to help students along. So this example here is kind of the most basic example of making a graphing question. You could have multiple points and do that different things with them. And the next thing I will go on to is the next level of complexity, but I'll stop here if there are any questions.
Hey, Lawrence, we had a couple questions come in.
Sure.
One of them is, can the presenter show us how to set the key without the letters A and B? So if the directions don't say anything about A and B, is there any way to set it so the letters don't have that?
The labels on the points. There is a little arrow, a pencil, an editor for the points. So if I hover over point C, I can also change this here and put it as my point. And I can also configure it with other things as well. I can label it with math and more. I don't know if all of that works, but oh, I forgot to save it. So let me try to edit my point and then save it. And so there's my point. Now, if I wanted to remove that, I could also do that. And I think if I just leave it as blank there, well, there's too many points. So let's reset it. And let me put my answers back again. Okay, so if we want to change point A, let's get the pencil and remove that label. So there's no label there. So I'll stop now. Was that the answer that was requested?
I think so. Yep, she says thank you.
Okay, we also have options here as far as ignoring labels, which is set by default. Now, if you wanted to actually have students label them specifically, then we would change that option. Here, I'll turn it off. And notice there's also these little hovers. If you hover over the I, it should explain what each of these options means. Some of them are complicated, and so I will close that. Okay, so let me go on to something a little more complicated, and I'll go back. And question 2. So here we are going to show, besides points, now we'll go up to something that's like a vector. And we want the student to create a vector of length 3 that has an angle of 45 degrees with respect to the positive x-axis. So that's the question. This is how I will go into the editor to see how it looks to be authored. So here I have set my answer with that vector. And I've also, I'm just checking if I'd set anything else. This is all I've set. You could change the objects, but here we just have selected the vector object. There's no, in the first question, I also had the point object. So here's our vector. Notice I started it at the point 1, 1, and it goes to 4, 4. Now the next step, we would see how this evaluates in preview mode. So let's try it with first an incorrect answer. I'm going to make a random vector that's not correct. And now check answer shows that that's graded incorrectly. Notice that it doesn't matter where I draw the vector. So here's a correct vector, but I drew it at different points because the system understands what a vector is. So now if I check the answer, it shows it is correct. So this is the idea behind all the graphing evaluation. It's flexible and it understands what these objects are. And so in the evaluation, it will evaluate the length of the object and the angle. And that's how these things work. And each of the objects has different criteria, and I'll talk about some of those later. So before I go on, because I skipped ahead, we started with points, but the other objects we have here that are sort of a more basic level, we have segments, polygons, arrays, and then vectors, and then lines. These 6 more basic, and then we kind of get into the conic sections where we have our circle, ellipse, parabola. There's different ways to generate parabolas, and then there's a hyperbola, and then we get onto other types of objects. There's a polynomial object. There's here, this is exponential, which is e. It's not exponent. I'll talk about that later. There's logarithm. There's trig functions. And area, which is used for inequalities. So to select shading, and dashed is also for inequalities. So those are the other graphing objects. So I will also pause here before I go into the next question.
Thanks, Lawrence. There was a question that came through about the points again. I missed it. It was in the chat. Will it mark it wrong if the labels are switched? So are the labels and the points?
Oh yeah,
important.
excellent question. Let me go back to that. Question 1, here it is. So I'll open it up again. This was under the options, which I was talking about, evaluation settings. So the default is to ignore the labels. So
Okay.
I will actually test that scenario. Let's go and change the label here. And I'm gonna make it AAA. So now, because I have ignore labels, it shouldn't matter what the student enters. And then the second one is -1, 7. So this one, we go in preview mode and check it. It still grades it as correct, even though the label is different.
Mm.
But if I had the option here as off, so now it's not going to ignore the labels. And I'll preview this one. Now this should be graded as incorrect or partially because A has the wrong label. So graded as partial. Right now, it doesn't tell you which of these points are correct, but that's something, the enhancement that will happen in the next couple of weeks. So A should really be marked in red here. They shouldn't both be green because one of the points is wrong. So that's coming soon.
Thank you.
Okay. So I will go on to the next question. Now we're going to look at polygons. So the question here is to ask the students create a right triangle with side lengths of 3, 4, and 5. And we need to give an instruction to tell the students how to do this. So for example, excuse my spelling mistake, we're going to tell them how to create their triangle. And so I've pre-created this triangle. And so I have the 3 points A, B, and C, but I'm going to redraw this. In fact, I'll add another one. So, and then last time I'll click back on D to close the polygon. So if I wanted to, let's see, undo it, redo, or let's see, there, it deleted it. You can make any sided polygon. So here's a different one, and let's undo that. So this is the answer that we want. So we've entered this as the expected answer. And now we want to look at evaluation settings because this has to be a triangle and have specific lengths. So now we have to go into these settings. And I've already marked the settings I need. So this polygon, it's a polygon check. It has a right angle. And I want to have the congruent option. You can also hover over the little eye to show, this means the student polygon has the same angles and sides, but the position and orientation can be different. That's how this will be evaluated. And I have the ignore label set again. So let's go through and check how this would evaluate. And I'm going to enter something that's incorrect and check the answer. And this shows in red. And if I show the answer, there's the answer. But I'm going to now redo this answer. And let's shift it somewhere like here. So since the evaluation knows that this is an equivalent form, it doesn't matter where it's located. So I put it there and check answer. Whoops, it shows it as wrong. What have I done there? Let me see. Have I hit a bug? Show the answer. Oh, it entered the answer incorrectly. No, 3, 4, and 5. Sorry, point C is not correct. So the AB has length of 3, BC will have length of 4, and AC should be 5. So there, check answer shows the right thing. Now, if it were up here, check answer, that also knows that that's a correct answer. And so if we also had a different form, this is still meets the requirement, and I check answer, it evaluates to correct. So this is the way that these options work. And in particular, there's other options for polygons. It can check the area It can also check if you have a square. This is for checking square. You can check for similar objects, the perimeters of the objects, and I'll come to some of these other options later. So I'll pause now if there's any questions about polygons.
Someone was asking, Michelle's asking, is it possible to grade as partially correct?
Yeah. So I'll go back to the partially correct. I was mentioning that earlier. So that will come under the scoring options. Scoring. Scoring, there it is. So this is the scoring type, and there's a partial match. So the way partial match works, it does depend on the type of question. So I showed before with points. Say the correct answer had 3 points and the student entered 2 of the 3 correctly. Then they would get 2/3 of a point. So it'll consider each point as a basis for correctness. If, say, you ask the students to enter 2 polygons and they entered, say, 1 of the 2 correct, then they would get half. That's the way the partial grading would work. So it does depend on the type of question. And we could try it here, but I think I did cover it before. And so I would encourage you to compose the questions and go to preview mode and check them out to see how they evaluate, and make sure that you have all the correct options set. Any other questions?
Katie's asking, does the student have to add the tools, or do they use only the tools you've added to the question?
Excellent question. Sorry, I should have mentioned that. So let's configure the tools. So the way, in fact, let's compose a new question from scratch. I think that will show it a little more easily. So I'll go back to here. So I'll make a new item, and it'll be a graphing item here. So it starts out like this, and by default, there will be the point and the line object. Now, if you want to change that, let's say we want to do just points. So we want to get rid of the line. You see the line is selected, and I clicked on the plus there to open up this menu. So let's remove line. So now it just has the point objects. And if you wanted to change it, if your question, say, was about, let's say, the sine function, we would add that. So I clicked on it to add it, and then we might remove the point. So now we've just enabled sine here. We may also enable to see if the student can use the right one. When they're doing trigonometry, I enabled sine, tangent, and secant. And then the student will have these 3 objects as well. And they might have to figure out which of them to use to create their solution. So that's a way you can control which object is presented to the student.
Great, thank you. And
okay.
Nicole said, I've seen some pre-made activities that have graphs with different colors. How do I create a graphing problem in which students can graph with different colors, like if they're graphing a system of equations?
So right now, there's no way for the students to really control the colors as far as graphing types. So these are all the, here's an example. There's no tools available for colors. There are options with different colors in some of the other question types, but right now not in the graphing. You have some options in the authoring of the question. So what is the equivalent? If this is your question, you can do things in the format in the presentation. So here's text color, and there's background color. There's all kinds of configuration options. There's also math mode, and you get all the math keyboards. And so that is part of the question authoring. But for controlling the graph, right now there's no color options. But that's something we could look at adding.
Someone just said in the chat, you can add the objects like a line and a second line, and the 2 lines will show up different colors.
Oh, okay. That's in the here in the drawing prompt with objects. So this is the drawing tool. So those colors will show here. Though it's, I should enter. Let's give the question. I think I have to enter some answer. There's 2 lines, and I have drawing prompt with objects. So yeah, so here's the first line and the second line. Yeah, so here they do come in different colors, but it's not like the student really has another ability to change the colors. Is that what that point was about?
I'm not sure. Nicole will have to elaborate that for us in the chat or Q&A, but that's great that it's 2 different colors. And kind of along a similar line, oh, she said, yes, that's what I was looking for. Awesome. Pedro said, maybe someone asked it before, but can you shade sections of the coordinate plane when graphing inequalities?
Oh, for sure. Thanks for the segue. That's coming up next.
Nice.
Is there any other question perhaps at this point?
We have a bunch of questions, so why don't we segue into that, and then we'll ask some more of the questions in a moment.
Okay, yeah, so definitely want to get to the inequalities. So let's go back. So in the 6 questions, we talked about plotting points, and then I had a vector, and now I showed a polygon. In question 3, it's a right triangle. And now I'm going to go into question 4, and you can see there's an inequality. We have x squared plus y squared less than 1 and y greater than 0. So the students have to graph the region that meets 2 inequalities. And here I've actually given these 4 objects. These are the ones the student needs to answer. I could also add a distractor, something different if wanting to confuse the student perhaps. Say we wanted to give them a polygon object as a distractor. That's another possibility, but here they would need to use these 4 objects. So I've created the answer where I've given the circle, and here the line, it's actually overlaps with the axis, so it's a little bit hard to see the y greater than 0. So I'm going to do this question again. In fact, there's a mistake here, so we have to fix it. I have x squared plus y squared is less than 1, and this circle doesn't meet that. And the reason is because I think it's snapping to a different grid. So here we'll have to go through and change the grid. We can see here I've configured the grid to go from -2 to 2, and the grid distance is 0.4, and that won't let us do what we want. So I'm going to change it to a quarter. Let's put that in there. And then the circle should be able to snap to the correct grid. Okay, so we're going to enter. Yes, it did. So the circle goes through. X squared plus y squared is less than 1. And there's the line. I could drag the line if I wanted to place it differently. I'm just showing here. And so these are strictly less than or greater than. So to do that, we use the dashed option. So dashed will change from solid to dashed, which means strictly less than or greater than. If we didn't want that, I could take that out, and let's see there. I just toggled. So now this would be the line y equals 2 or x equals 2. In fact, I had another mistake. Y greater than 0 is not this. In fact, let's delete this line. So I'm going to redo the line y greater than 0. In fact, we could make it more interesting. Let's make this y greater than 1 so it doesn't conflict with the axis. So there's 1. I need to enter 2 points to create a line. So there's the line y greater than 1. Now y equal to 1. And if I wanted to make it strictly greater than, I need to use the dashed. So I selected dashed and then click on the line, and it will become a dashed line. So right now this just intersects a circle at 1 point. It may not be ideal, so I'm going to make it y greater than 1/2 and drag this down, and it should snap to that half grid. So there's how I created the line. And I'm also going to remove the shading So the shading, the region between these two is this with the brown diagonal lines. So let's see. I might have to delete it and then show how it looks. So I just deleted and clicked. Let's try that again. Maybe that doesn't work. Interesting. Oh, there it is. Sorry, I had to wait for it to happen. So here I just have the two shapes, the line and the circle, and I'm going to fill it by using the area mode. So the correct intersection is y greater than 0.5 and x squared plus y squared less than 1. I'm going to click in there, and then that shades the region. So this is the way the inequality can be used between two objects. And so I don't need any other special evaluation settings for this. And we can check it in preview mode. So, or let's do this with partial credit to make it more interesting. So this should give credit when part of the answer is correct. So let's go here and simulate what the student would do now. In entering a circle, we may not be sure how the object works. So I'm just going to enter like this. I saw it took 2 points. Point A, the first point will always be the center, and then point B will be somewhere on the perimeter. And so I have to adjust this to get the circle I want. So I moved B to this point, and now I have the circle. And this is a strictly less than, so I will make it dashed. And let's enter the line. So I'm going to enter the wrong line. This is not the correct answer. And I'm going to select the inequality. I'll shade that. So part of the answer is correct. I'm not exactly sure how this is going to evaluate in partial credit, but let's see what happens. So this didn't quite work because partial credit is kind of tricky. Let's see if I try some other scenarios. This is why the preview mode is good. Check answer. It's still not giving that as partial credit. Check answer. Okay, now I'm going to change the inequality. There's some delay in generating the area. Let's see. Okay, there, I got that one, and I'm going to turn this one off. Maybe I have to use the delete. So I'm waiting for this. Oh, there it goes. There's just some delay in removing the shading. So now I have the correct answer. Let's just check this. Oh, okay, what did I do wrong? Okay, maybe this is a question for the audience. Does anyone know what I did wrong here? We can pause. Has anyone in the chat spotted my mistake?
Someone said try what Andrea said, which is click the circle. Someone else says it appears you have to click on the little brown circle to delete the shading.
Yeah, that was for deleting the shading, but I have here the correct answer.
Someone said try the labels of the line.
I should have
set to ignore the labels.
Yeah, I should have the ignore label set. Let's just check. I have ignore labels on.
Is point B in another location?
Show the answer. There's A and B. That could be a bug. I'm going to go through and do it again. I'm going to make point B there and make the line. And select that. Okay, that should be the correct answer. So I have answered it correctly. My other suspicion is maybe the partial credit didn't work properly. because this is kind of a new thing, the partial credit. So I'm going to put that back to exact match and check that that works. Unfortunately, I have to go and do this again. Okay, check answer. Huh, strange. So this is what happens when you're trying to demonstrate something and it doesn't work properly.
I'll have to get back on that one. I do want to do a quick time check. We have 15 minutes left in our designated hour, and I know we have a bit more to get through and a lot of questions coming through.
Yeah, let me go through into the last two examples. I apologize for this. I'll have to follow up on this after the meeting. And so let me go through the next examples. So question 5, we have an inequality, so it's kind of the same as before. So in this case, we wanted to graph 1 plus 2 sine pi over 2x. And so that is using the sine object. And again, we have area, and I've selected the answer here. So when entering the sine object, point A will be the midpoint between two crests, and point B would be the second point on the top, the highest point. So some instruction would be needed to explain how the students could generate this, or you could see if the students could figure this out for themselves. So that's kind of quickly on that one. Maybe I'll go quickly to the last example. This is the last one is very important, so I do want to show this. So now you have a general equation, and so this comes to this option here, which is the student. This is, I would call it general graphing. You want the students to generate any function, and here they should enter some number of points, say 5 points, that meets a specific equation. And you could type it in, here's an exponent of x. So, and these are the number of points you want the students to enter. So I could go back to 3. And in the preview mode, the student would see it like this, and they would have to enter their points. And the system would grade whether these 3 points meet this function. And you could also use tolerance depending on the grid, how close the students have to be. And this should also work with partial credit. So if the student has 2 of the 3 points correct. And we will also be adding, it's not here today, there will be a button here which should join the points. So it should make a sketch just connect the points. So this was just an illustration right now. This feature is not quite working. I just wanted to show what should be there, hopefully working by the weekend. So if you wanted to try this again on Monday or Tuesday next week, this should work. So if I did a check answer, it's not evaluating even though my answer is incorrect. This type of question won't work properly. So this was here, I'll show again, the student needs to identify points on an equation. All right, so those were all the examples I was going to show. Ileana, what should we do next?
So I think if you could show how to draw a simple linear inequality, I think that is something that people are asking for.
Okay, let's do that. So I'm going to create it from scratch.
With shading.
With shading. Okay, excellent question. So let's go back and let's author a new question. So I'm going to start in graphing, and let's just use lines because it's a linear inequality. And I like to do the easiest line that I can always remember is y equals x. So to create the line, we need any 2 points on the line. So I'll give it -2, and 2, 2. So I've created the line, but this is going to be an inequality. So we also need to include the area and dashed function. So the area will allow us to select the side of the line we want, and dashed is whether it's greater than or equal to, or less than or equal to. So let's graph y greater than x, for example. So here we'll have to use the dash to change the line so that it's not considering the equals to, and we will select the area we want. So I put 1 point to select the area, y greater than x. And so let's check the evaluation of this. I'll go into preview mode, and I'm going to enter different points because no students will enter exactly the same points. So we'll use 0, 0, and maybe 7, 7. So I have the same line, and I will make it dashed, and I'll select the area. So here's how the students would compose it. And let's check how the evaluation would work. So here it did the correct thing. It shaded in green. So this is a basic example of how to do linear inequalities. And you can also do more weird stuff and enter a second line here and make the questions a lot more complicated. And here you'll see the shading updates in real time, but there's some delay while the shading is working. And we can also go really crazy and add a circle. And see how the shading updated. So there's some delay in updating the shading.
Awesome,
okay,
thanks.
so that should show this example.
And then we have questions coming in about how would you do a parabola or a hyperbola?
Oh, excellent. Yes, I wanted to cover that. Okay, so let's reset this one. And now let's go back. So we don't need line, circle, and we'll forget about the inequalities for now. There's two modes of parabola, and we might add more modes later. So let's pick this first mode, and you can see there's a little 1 and 2, and this one has a 1, 3, and 2. Now this mode 1 and 2 is actually the 2-point mode to generate it, but it can't generate every type of parabola. So it has to make some assumptions. And I'll also make this other parabola type available. So for this mode, it only requires 2 points. The first point is the vertex, and then the other point is a point on the arm. So here's A and there's B, and I can also move the points around or pull this to change it. And I can also I can move that. Oops, I didn't mean to do that. I'm going to do it again. Can move the parabola around here. But this only gives me these controls over the parabola. If I had this other mode, reset here, now this has the directrix and the focus mode. So it needs 3 points. So I'll enter the first 2 points, 1 and 2, on the directrix, and the third point is the focus. So I think this is wrongly labeled because this, here it is. Actually, you see where it says the 1, the first point is the focus. So let's do this again. So the first point was actually the focus. So I'm going to put it up here. And then the next 2 points are on the, I messed up. Reset, select the mode. The first point would be the focus, and then I'll make 2 points on the directrix, and there's the parabola I wanted. So those are 2 modes for generating parabolas, and you may not be clear what these do. So in the near future, once you move the mouse over it, there should be a little pop-up that explains how this works. And we also have help pages that explain this. Maybe we can take one more question and then we could go to show those help things and what we're also working on in the near future. Should we take one more question?
Yeah, sorry, I was muted for a second.
Okay.
So just to point out to Andrea, the hyperbola is on that same menu if you wanted to do that.
Yeah, exactly. So
and then
hyperbola has 2 focus, the 2 foci, and 1 point on 1 arm to generate it. There's also a polynomial here, and the polynomial one's kind of cool. So maybe I'll just show that. So generate, let's say y equals x cubed. I need 3 points. And then I need to come back to the first point to close it. So I'm going to click back on A. Oh, what happened there? That was not what I expected. Let me reset it. So polynomial y equals x cubed and 2, 8. And I can give it one more point. And now I have to go back to the first point. Oh, there it is. So that's how you can render polynomials. And then the points can also be moved around to generate more fancy things. So let's go to the last few slides.
Sounds good.
The things that are coming soon. So we're going to have axes in intervals of pi. So instead of intervals like 0.25 or 1, this will be like pi over 4 or pi over 8. You can configure it. And I mentioned before, mousing over the object should explain the implementation. And we're working on adding tolerance. There is a tolerance feature now, but I think it's too difficult to figure out what it does. So this tolerance that's coming would be in terms of the points on the objects and as like a percentage or absolute amount of the grid. So if the grid's 1, you could specify a tolerance of 0.1. So the student points that meet the object should be within that tolerance. And connect the points on the draw the function. If they have like 5 points, this will connect the dots. We're working on adding more features for piecewise functions, including like open circles. And dynamic parameters are not part of the graphing right now. So there's only one version of the question, but we're going to make this work with dynamic parameters. And then you could have different versions of the questions. And supporting of polar grids. And lastly, I'll mention where to find more information.
If anyone has any final questions, please put them in the chat. And I mentioned or in the Q&A, please. Okay. And before we answer some more of the questions, I do want to do a couple of the final things that we have for today. So one of them was our Spark Math giveaway winner. So my colleague Jan picked a random name out of everyone who's attending today, and it looks like Kathleen Comack is the winner of our Spark Math subscription. So congratulations,
Yay.
Kathleen. To everyone who's joined us today, thank you so much for joining us, and we hope you'll stay in touch. We are on Twitter, Facebook, Instagram, LinkedIn, and we would love to keep you updated and also hear what you have to say. So stay connected with us there. So thanks everyone again for joining us today for our graphing training, and we look forward to supporting you with education moving forward.